the class is going to be a little bit different now. We have introduced to you general concepts of the human situation, the development of human society over time, the development of the ways in which humans have exploited resources over time. And now what we want to do is bring into you a suite of experts, both from outside ESF and from inside ESF. So we will have people here with urban ecology and all kinds of other different things, but conservation biology, etc. Now what we have today is the first of these experts, my good friend Tsutumo Nakatsugawa, and he's professor in Illick Hall. He grew up in Japan, and he tells me his first memories were there were hardly any trees because they were tearing up all of the trees to make turpentine to put into their airplanes so that they could go and fly against my father. And I find it very interesting that our fathers and uncles and so forth were arch enemies and we're the best of friends. So much for that. So he is going to come and talk to you about the general process, the general concept of chemicals in our environment. So welcome Dr. Nakatsugawa, please.
Dr. Howard just said you guys went through the long-term conceptual things, probably spanning thousands of years or maybe millions of years. And I'm talking about something more recent. I think we are talking about chemical pollution, so-called modern chemical pollution. And it's important to have a historic perspective of the issue. You have taken history courses, I'm sure, and president's name and battles and all that is not important. What goes on behind those with ordinary people is a whole lot more important. There is the word age of chemicals. The age of chemicals refers to this age that we are in, where chemicals coming out of factory permeate all corners of our life. And that started just about with the end of World War II. You know when that was? 1945. I was a little kid at the time, but most of the major pollution that people talk about today occurred from that time on through maybe 1960s. After that, we've been busy trying to clean up and also control, not to pollute more than that. But it's a relatively short time if you think about the whole span of history. So the age of chemicals had impact since the mid-20th century. The organic chemistry started in Germany about the turn of the century, about 1900 thereabout. And that's important to recall, because at the time, lots of things are going on. Towards the end of the 19th century, only then people had the idea of the cell, the idea of the germ theory, and all those things came about only towards the end of the 19th century. And what's important is that at the time people were living on the average much shorter than today. The life expectancy is a concept that takes a little more explanation than today. But the life expectancy of U.S. population about 1900 was not much more than 40 years of age. And many people died from the young age all the way to the old age, fairly routinely. The causes of death were not cancer, not cardiovascular diseases, not auto accidents, lots of other things, mostly contagious diseases. And tuberculosis, dysentery, pneumonia, influenza. You can probably name quite a few others if you have read anything about the history of that time. If you go some towns in the state of New York, you find, I heard, villages where many people were killed by malaria. So you can read the tombstone. And it's probably strikes you strange to think of malaria as a U.S. Killer disease. But that was a major cause of death. So that's just one example. And so people's concern was not so much of a chemical pollution, but the microbial assault on you, and then the nutrition in general. People died of lack of vitamins. And then the pollution occurred against that backdrop. And so people's concern changed. And with it, of course, science changed. When you think about pollution, many people probably think about pesticides, and that's what I used to teach as a single subject. Organic farming is a great thing, and I'm all in favor. I invited a few students a couple of years ago and did a little work checking out what's available as information on organic produce. And so this is a report from seven students. Organic produce 2000. So if any of you are interested in deeper end of that, it's here. But this is sort of an example of people's idea of pollution. We are living in a polluted world. Well, when it comes to pesticides, it's changed the whole. How many of you know DDT? Okay, almost everyone, right? And that's sort of a symbol of bad thing about DDT. About the pesticides. And that's because that was the center of focus of Rachel Classman's Silent Spring in 1962, that was published. And then suddenly society became aware that DDT disrupted the ecology badly. And also, some people thought that caused a cancer in humans. And so people still think that pesticides are like that. But during the 1970s, a big change occurred, and almost all the so-called non-degradable pesticides being pulled off the market. And today's pesticides are all biodegradable. And also, the regulation is such that the amount you encounter on or in your food supply is reduced a great deal. I would explain the process of estimating how risky that residue on the food is to your health in my other class, but it takes a little longer to explain to you. But EPA does it in certain ways. And according to that, the risk from the current bunch of pesticides is quite small. So buying the organic produce for your health purposes probably isn't very meaningful. For promoting the organic farming, it is very meaningful. Soil erosion is the biggest agricultural problem this nation as well as elsewhere faces. So in that sense, organic farming is a very important subject. But health risk of pesticide residues, without getting into the detail, let me just tell you, very, very low compared with many other things. EPA sets a standard and try to keep all the pollution that they can control below such level that lifetime cancer risk you face, if you're exposed to that particular level for your life, the probability of dying of cancer is 1 in a million. That EPA considers as insignificant. Now you say, hey, this country has 260 million people. Means 1 in a million means 260 people are sacrificed. Well, it's not that kind of a hard number, really. And if you really think about outcome of 1 in a million probability of death. If you look at the serious disease, it must occur every so many decades once, because each year we don't lose that many. I'm not advocating use of pesticides, simply telling you the number of the risks. Okay? And back in 1920s, this is before the age of chemicals. Several British subjects fell ill eating apples. That's an old-time problem. Apple came from North America, probably stayed from New York, and they got poisoned. Turned out it was a lead arsenate on the surface remaining on the surface of the apples they were eating. I guess they didn't peel. They should have. So they got sick because there was too much lead, too much arsenic on the apple. And in fact, the U.S. Authorities were beginning to be concerned about the amount of lead arsenate residues on apples at the time. This is 1920s, okay? And at that time, the regulation was not pushed by the people. It was sort of paternalistic regulation from top down. So the authorities are concerned. They were aware there's too much lead arsenate remaining, because you can see it white. So sure enough, British got poisoned, and then British had some authorities to regulate the arsenic. So they enforced the law. They didn't think about it until that happened. And the U.S. also had to oblige. So they met the international standard, which means British standard at the time. And they instituted washing of apples as harvest. So apple washing machine was common sight across the apple growing region in the United States for a few decades. So the obvious level of lead arsenic is gone by then, but it's not zero. I mean, by today's standard, the residue remaining at the time is horrendous. But they didn't think about cancer. The lead is a human carcinogen, we know that. And arsenic is human carcinogen. Lead arsenate is an armless combination. But that was a mainstay of pest control in those days in this country. And then they sprayed 6-7 times a season, several tons per acre. A lot of lead arsenic. And so some of the old orchards around here probably contain quite a bit of lead and arsenic still, but they don't go away. That was back then. And today, the way we are concerned about our own pollution risk is so-called calculated risk. Because you don't see anybody dropping a bag of becoming ill, eating non-organic food, right? You know it's somewhere there, but you can't see it. You don't get ill. So EPA does a calculation based on animal studies. You feed the various pesticides to the animals every day, and then continue for 2 years, and that's called chronic. And that way, you get some idea of the risk involved at the high dose, and then you extrapolate to humans, and there's not so clean-cut process for that. And anyhow, EPA calculate and then try to make the level now to the cancer risk of 1 in a million or less. And cancer, of course, is not the only concern. And you have heard of environmental estrogens or hormonal chemicals. That's perhaps a bigger issue today. But those are all calculated risks. And it's very important to realize that there are different kinds of toxicities. The old-fashioned one tend to be more acute toxic effect. Acute means you see the effect within a matter of minutes, hours, days, maybe a week. Chronic toxicity, on the other hand, we are talking about fairly repeated, regular exposure. And that's the modern pollution concern. When we talk about types of pollution, there are cases where the immediate effect is important. Chernobyl, of course, you know, is a nuclear accident and caused all kinds of cancer, including the thyroid cancer in Russia and also in the rest of Europe. You know about Exxon Valdez, spill of oil. All these accidents, and both human health-wise, ecologically, it's an acute effect you are concerned about. Then, of course, the long-term effect will drag on after that. But for the most part, modern pollution concern is coming from something a little more subtle. First one, I listed the waste from population, municipal wastes from transportation. Control is such that pollutants are now colorless and you don't see it, but pollutants are there. And of course, there are a lot of gas stations that can emit, that they treated with the emission of gasoline components. I'll get back to it later. Secondly, this is the big one, quality of life trade-off. I mentioned pesticides because that's a major cause of pollution, large or small, because we want to use pesticides. Now you say, no, you don't want to. Well, perhaps you don't want to, but if you don't use pesticides, you have some other problems, like fluctuating food supply. And you never really had real hunger here. And you have seen the pictures of the famine going on in Africa. It's just awful. Skin and bone liver. And around here, I'm starving is simply expression. So pesticides.
Tell them about what happened when the first U.S. soldiers you saw and they sprayed you with DDT.
Yeah, I was covered with DDT. I was quite happy to get that. The reason is that I was infected. Well, I was not the filthiest kid in the block. Whole towns around Tokyo were infected by either lice or fleas. In my town, it was fleas. I'll tell you, it's awful. You harbor about 2,000 fleas around your belt, seams, shirt, okay? And that bites you constantly. And then nights are awful. You can't sleep. So when you wake up and then catch them and then squash you between your thumbnails. And then I killed about 2,000 every night. And then you have bite every square inch, there's a bite. And those are all, every kid. So the US Armed Forces came when Japan surrendered. And then the first thing they did was they came with a little canister containing talcum powder and DDT mix. And then they put a little nozzle back of my shirt, in front of my shirt. And you are in the smoke of DDT. And miraculously, overnight, it's all gone, no itch. So, of course, in our case, it's a quality of life of itchiness. But in other towns, it was more serious. You know, typhus is transmitted by lice. A lot of people came down with typhus and got killed. So that was more life-saving. So that was just, well, that's one reason why I don't really talk all the bad things only about DDT. There are some good things. And of course, in this world, this is getting a bit philosophical. No such thing as all good, all bad. It's all grayscale. It applies to everything, including myself. I used to think I was perfect until I got married. It's always that everybody has some kind of a defect, and I have plenty. And so DDT's case, saving the life of millions across the world was a great thing. And then Paul Miller, the discoverer of DDT's effectiveness in Switzerland, he won the Nobel Prize for that contribution. So it's a great thing to save life. But Dr. Bartlett,
yeah.
You know the population issue, right?
Remember when he listed as the goods?
At the end, right? I know that talk. At the end of his talk, he tells you good thing, bad thing. So DDT was a good thing and bad because that was the most effective population death controlling agent as opposed to birth control agent. Industrial discharges and waste, this probably you know that too. Unfortunately, Japan, being a small country and industrialized, and with a lot of people, about half as many as the US, and had its more than its share actually of pollution and industrial discharge problems. The Minamata disease was the mercury poisoning of people. Actually, people were poisoned by mercury. And Thai disease, the cadmium poisoning, and so forth. I think every nation has some spots where real dirty story exists. In this neighborhood, I guess, the town of Asbestos in Canada was one of the worst. The miners who took asbestos from the ground in early days came down with all kinds of problems. Asbestos has 3-4 different lung-related problems. That's industrial discharge and related pollution problem. And so if you look at this, the pollution is related to the amount of population, the number of people, population times each of these factors combined. So fewer the people, the better off we would be as far as pollution goes. I think I'll talk mostly on the quality of life area from this point on. And humans have been trying very hard to break away from nature, balance with nature, and everybody loves nature. You want something natural, and as I said, everything has two sides. Nature has a lovely side on one hand, and on the other hand, nature has bad things. So the nature threatened human existence, of course, like any other species. The security of food, clothing, and dwelling was an important issue. Of course, all the technology and people's effort went into it. So we are far better off today than back when. Dr. Hall probably talked a lot about petroleum as energy source and feedstock and so forth. And you know, the petroleum use is only a century old in this country, isn't it? Approximately a century or so. And before that, this was not helped by petroleum, but rather people had to build their buildings with wood, clothing from the fiber from the plants. So the petroleum is a good thing that came. Much as you hate the pollution from petroleum use in the chemical industry, now you are stuck with it. I don't think you are willing to go back to that old time. Well, certainly in order to go back to old time, you've got to reduce the population. Okay? 9 out of 10 have to go. So freedom from disease and premature death was an important thing. And hard labor, you tend to forget, because this is a country of mechanized work. The farm is done by machinery, and you think about all kinds of ingenious method of not working yourself with your muscle. There's like a victory garden in this country. During the war, people have to appreciate how hard it is to, support everybody else. And so we had a little school garden where we grew rice. You got to bend down and weed. Otherwise, weed will take over. You don't have any rice. And so 2,4-D, the most famous herbicide, was extremely important and alleviating, lifting this burden from the farmers. Now farmers just spray this thing. There is a risk, of course, but which one would you do? If you're a farmer, you gotta bend down all day long, or just spray. So that's a trade-off. And so all this, I just want you to realize that pollution's group is that type of a thing. back to this pollution health issues. I told you about apples. And the dose makes the poison is the most important statement in toxicology. Any toxic effect depends on the dose and the amount you get. So amount is low, the dose is low, effect will be less and then perhaps non-existent. In the cancer case, EPA assumes there's no threshold below which it is safe because, well, they say at least some of the cancers caused by change of DNA, and all it takes is one cell mutation. So however small the number of molecules are, if that one molecule survives through all the processes, get to the target, DNA damages, and then that boom goes into the cancer, there is finite probability. It's not zero. However small it is not zero. So EPA used that assumption as the base of extrapolation. And then with the help of a statistician, applies the computer mathematical model and fit that animal data to that, extrapolate to a low level, and then try to estimate what it takes to have the cancer risk as 1 in a million lifetime risk. For US is the only country in the whole world that does that. Nobody else will do that. Everybody else is assuming same sort of a thing for cancer, carcinogen or non-carcinogen. And I cannot tell you one is right, one is wrong. It's not that simple. With this, at least we are controlling our pollution. And I don't have time to go through all kinds of pollution, but I'll pick a few that you probably know. EPA calculates, of course, the risks of cancer for all these. And I'm talking about cancer a lot because that's the way EPA operates. But don't get me wrong, there are other effects, okay, that we should be concerned about. You know benzene, you have taken organic chemistry or chemistry, you know what the benzene is. You know 6-member ring, aromatic ring, okay? That is a couple % of gasoline. So everywhere there's a gas stand, there's benzene in the air. So in industrial nations, if you live in the cities, you get certain amount of benzene pollution, whether you like it or not. You breathe in, breathe out, probably you absorb most of it as you breathe in. And you breathe, according to EPA had those reference numbers. We are supposed to inhale 1 cubic meters of air per hour, or 20 cubic meters per day. Okay? And if you can calculate from that, this calculated risk. And you want to have that below this 1 billion magic number, right? Then you consider that's safe enough, insignificant risk. Unfortunately, benzene level in the city don't come up like that. It's about 100 times too much. You're exposed to benzene every day, day and night. You don't smell it, it's so low. Now, this all depends on the process of EPA's calculation. If the assumptions, there are several assumptions, important ones. If all the assumptions are right, then you can say pollution level by benzene is 100 times too much. Unfortunately, none of those assumptions are that firm. So it's not something that you should jump up and do something now. It takes a while to do any kind of remedy. How many of you know aflatoxin? Aflatoxin? None of you? How many of you eat peanut butter jelly sandwich? Okay. If you eat peanut butter jelly sandwich, there's a fair amount of peanut butter on top. every day, now you probably don't do every day, but suppose you do every day. Then you can calculate the aflatoxin is the mold metabolite from black mold that grows on peanuts and many other grains. Peanut is one of them, of course. Pistachio, the same thing. And the amount of pollution there is very, very low. But you can detect it by fluorescent black light. You can see it glow, blue or green. And aflatoxin is one of the most potent liver-specific carcinogen known. So if you calculate the cancer risk from aflatoxin, eating peanut butter sandwich every day, it comes out about 100 times too much again. Do I not eat peanut butter jelly sandwich? I do. Because I don't think the assumptions behind the procedure is all that terribly reliable. And then I'm not quite ready to give up the flavor of peanuts once in a while. But I wouldn't eat it every day. Dioxin, everybody knows dioxins, right? Dioxins, we are all exposed to dioxin, depending on whether you are a meat eater or not meat eater. Meat eater tend to get more because meat is the major source of dioxin, as far as we know. And the risk factor calculated may be 100 to 1,000 times too much. Again, this all depends on, I gotta emphasize, this depends on the assumption, okay, behind the method. So, this is simply a small example. Now, I haven't told you too much about what we eat normally so far. But you know, what we eat is not all that benign. The mother told you to eat the vegetables, and I agree. Eat your vegetables, okay? That's the bottom line. But your vegetables are not benign. Carrot, for instance. If you grind up the carrot, organic chemistry, extract the chemical from that. Carrot has several dozen chemicals that somehow we think the carrot evolved in defense of itself. It contains some chemicals that is a potent nerve poison. Unfortunately, it hasn't been studied much. But the potency of this nerve poison is about on the par as a typical insecticide you can buy at the Wegman or the Chase Pit, and in the spray. And it can kill the animals at the rate of, well, if you apply about 100 milligrams of that stuff per kilogram of body weight, that's sort of expression, you can kill them. And then carrot toxin, called carrot toxin, reasonable, it can kill animals with about the same amount. Now you're concerned about the pesticide residues from that spray can, so you really certainly don't want to spray that in your backyard vegetable garden, right? But if you do, you probably get maybe a fraction of a milligram of that pesticide. But if you eat 100 grams of carrot, which is a good sized stick, you get a few milligrams of that poison. It's still way below the poisonous acute toxicity level, so you are in no danger at all of poison, but you are getting it. You like a pizza with mushroom? I will always order pizza with mushroom. The flavors are nice. Mushroom, many mushrooms contain alkyl hydrogens. Alkyl hydrogens range from very weak to very potent in carcinogenicity. It can cause cancer in animals. Fortunately, most of the alkyl hydrogen in the mushroom is not that potent, but it hasn't been studied all that much. And then you sprinkle black pepper on top. Black pepper contains piperine, which is a nerve poison, excellent insecticide, and a carcinogen. on mice. You can paint huge, this is a huge amount, but it can cause cancer in mice. So how little is small enough as a risk? So if you look at all this Mother Nature's gift to you, that's why I call it Mother Nature's rich. And there are lots of toxic stuff. We have the mechanism to cope with them. We have evolved, right? So there is a method to get rid of. As long as chemicals are so-called biodegradable, we can get rid of them. So to a degree, it's okay. But if we apply EPA as a calculation procedure to all of them, you really don't want to eat too much. But I don't quite trust that method that far. So eat your vegetables. Okay?